So we are going to talk about rational expressions, which a rational expression is the quotient of two polynomials. So if you have two polynomials that are being divided, that is what a rational expression is, kind of like a fraction with some variables in it. The domain of your function, quick reminder, is the set of all real numbers for which your expression is defined and gives you real numbers out. So domain consists of all the values you can plug in that give you real numbers out. They can't make you do things like divide by 0. So in the example that I just gave you, you can't have a value of -4 for x in your domain. Everything else would be fine. If I want to write my rational expression in lowest terms and give the domain, first thing I want to do is factor, so that I can see if I have any common factors that'll divide out and reduce. So I'm going to factor a 5p out of the denominator, and then I like to guess and check factor because I'm pretty quick at it, but if you'd prefer to break up your middle term, find the two numbers that multiply to -8, add to 7, factor by grouping, you can. So once you've got it factored, you have a common factor of p plus 4, so p plus 4 divided by itself divides out to 1, and then you're left with 2p minus 1 over 5p. No more common factors, so that's your lowest terms. Now for the domain, it's easiest to look at your factored version of your original. You can't look at the final because we're talking about the domain of the original expression, and even if some factors divided out, we still need to think about them in our domain. So you can't have the denominator equal to 0, so I'm going to set it equal to 0 and see what I need to exclude. So if either of those two factors equals 0, the bottom will equal 0, which means that you can't actually have p equals 0 or p equals -4, because those make each of your factors equal to 0 and would make your denominator equal to 0. So you can say all real numbers except 0 and -4, or you can use our interval notation and say everything from -infinity up to -4, skip over -4 itself, up to 0, skip over 0, and then 0 to infinity. We are gonna multiply and divide some rational expressions. So if it's a simple one, I usually just go ahead and multiply straight across. So 3 times 10 gets you 30. Add your exponents on your y's, you get y squared. And then look for common factors. So you can divide out a 5 from 30 and 5 and get 6 over 1. There's an additional factor of x on the bottom compared to the top, so you can subtract your exponents, and you just have 6y squared over x. If you're dividing two rational expressions, you need to multiply by the reciprocal. So leave the first one alone, multiply by the second one flipped over, and then I'm not going to distribute anything because it makes it easier to divide out common factors if you divide them out first instead of multiplying it together and then factoring it back out. So I'm just rewriting it. And then I'm going to go ahead and notice that 2 and 6 are both divisible by 2 and turn that into 1 over 3. And then if you look at your factors that you have left, you can factor a 2 out of 2k plus 8 and a 3, and there's that 3 that was already there, out of 3k plus 12. And then your k plus 4s divide out to 1, and you just end up with 2 over 9. If you look at this one, there's a lot more factoring to do, so it's way easier to factor first than it would be to distribute that everything together and get a mess. So if you factor out your common factors, and then the second one's going to factor into m minus 5 times m minus 5, and you can factor out a 12. Again, I'm going to kind of reorder things here and just rewrite it. So I have 3 on top and then 3 factors of m minus 5. And then on bottom, 12 times 4 is 48, and then 2 factors of m minus 5. So you can reduce your, actually let's divide out 2 factors of m minus 5, divide it to 1, and then 3 over 48 is 1 over 16, so you get m minus 5 over 16. So we're looking for the expressions that are equal to -1. So first thing I'm going to do is it's only equal to -1 if you have the exact thing top and bottom except opposite signs. So if you look at B, you could factor a -1 out and then divide out your factors of x plus 4. So you just have -1. So that one's equal to -1. if you look at C, it doesn't really look like that would equal -1, but the bottom is actually the exact opposite of the top. So if I factor out a -1, that'll switch my signs to -4 and plus x, and then you have x minus 4 over, I'm just going to reorder it so it's easier to see, a positive x minus 4, and then x minus 4 divided by itself is going to be 1, so you also end up with -1. None of the rest of them are going to give you -1.